Hello and welcome to this invited talk on optimization in practice. My name is Andrea Rendl and I work for the optimization company Satalia. Today I want to share my experiences from working in industry, and in particular I want to talk about the unexpected challenges that I have faced. I started my career in optimization like most people in academia, first with my master's, then with my PhD at university. After that, I slowly transitioned into applied research, and for the last 5 years, I've been working in industry. This has been a really interesting and exciting journey, and I believe I got the perspective of both the academic and of the industrial world. During this time, I've made a couple of observations that I want to share now because they highlight the motivation and the core of my talk today. The first observation I made is industrial problems are notoriously hard. This is not going to surprise anyone. Still, in particular when I was a young PhD student, I was intrigued by the size and the complexity of these problems. And when I entered applied research, I was even slightly intimidated by it. But I soon made another observation. Our community is incredibly successful in solving these notoriously hard problems. And when I say our community, I'm not just talking about constraint programming, I'm talking about the optimization community at large. Mathematical programming, meta-heuristics, etc. We are really good in solving these type of problems. Still, after some time working in applied research, I made another observation that was slightly worrying. Most industrial projects never make it past the prototype stage. So what is the prototype stage? The purpose of a prototype is to evaluate the benefits of optimization for a client. Typically, the prototype is evaluated on historical data, but not on live data. The next stage after the prototype stage would be applying the optimization algorithm in practice on live data. But this rarely happens, and I didn't understand why. It was confusing to me, it didn't make sense. If we are so incredibly good in solving these type of problems, then why are so few of our algorithms applied in practice? It took me some time to spot the flaw in my reasoning. But after some years, in particular when I started working in industry, I made another observation. Optimization in practice is hard, but not because the problems are hard. It's hard because there are several challenges that we also need to tackle on top of the hard problems. We rarely talk about these kind of challenges, and I did not expect them. But I'm going to talk about them today. In particular, I want to talk about 4 challenges that I think are particularly important. Gaining the client's trust, scoping the problem formulation, dealing with constant change, and monetizing optimization to make a living as an optimization company. At first glance, these challenges might seem to be very high level and not very technical at all. But in this talk, I will show that there are also very technical aspects for addressing these kind of problems. I will also show that the CP community is already conducting some research that can help alleviate these challenges, and I think that is very exciting. Now let me share the outline of today's presentation. First, I'm going to talk about 2 industrial optimization problems, a last mile delivery problem and a workforce assignment problem. The reason for this is that I want to provide you with some context for when I'm going to discuss the unexpected challenges later on. Furthermore, those 2 examples exhibit very typical features that you would see in industrial projects. And I think that for those in the audience who have no experience working on applied projects, these examples might be particularly interesting. Furthermore, those 2 projects are success stories. They started as small proof of concepts and have now been rolled out to several clients. After discussing the optimization projects, I'm going to talk about the unexpected challenges. I will discuss what they are, and I will make some suggestions on how we can tackle them, and then I will wrap up. So let's start with last mile delivery. Satalia delivery is a product for several problems in the realm of last mile delivery. In particular, I want to talk about a problem that is a vehicle routing problem that is designed for clients who sell products online and to distribute their products with their own fleet. So an example would be a supermarket chain where customers can make orders online and the supermarket chain will deliver those products with their own delivery vans. So what is the underlying problem? Whenever a new order comes in online, like the gray box we see down here, the aim of the algorithm is to insert this new order for the specific time window and with the capacity it requires into the existing schedules of the vans. This means we perform an insertion step and insert the order. And afterwards we perform also an optimization, an improvement step to improve the current schedules of the vans. This is known as the online capacitated vehicle routing problem with time windows. Let's have a look at the problem size. The instances we see are extremely large, and particularly during the COVID lockdown, when the demand has increased substantially, the demand has almost doubled. What is also quite important is that the solving time budget we have is very small. We only have 200 milliseconds because the insertion has to happen in real time while the customer is performing their purchase online. We also have very little time for the improvement step, and this time depends on the traffic that we receive. So if a lot of orders are coming in, we have much less time for improvement. So what has been the benefit for our customers for using Satalia delivery? With Satalia delivery, our customers have been able to improve their last mile delivery substantially. They have been able to save a lot of mileage, they doubled their capacity, and they also substantially increased the number of orders that they're able to drop per hour. Another very good success story is that during the COVID lockdown, our clients have been able to handle the impressive demand that they had. For instance, 1.2 million orders per week in the UK. We don't exactly know the monetary benefits that our clients have made, but we estimate that in particular for this large supermarket chain, it's in a double-digit million pounds per year. Now let's move on to the next example, Satalia Workforce. The Satalia Workforce product is aimed at solving the problem of assigning workforce professionals to specific clients. And one of the largest accountancy firms is a client for Workforce Satalia. So what is the underlying problem? We have a workforce of professionals that we want to assign to specific jobs. And the professionals and the jobs have specific features. So they have specific qualifications that are necessary, locations, etc. So this is a classical assignment problem. And it's particularly difficult because we see a lot of constraints, hard constraints, but particularly we see a large amount of soft constraints. This is very common in industrial problems that we see a lot of soft constraints. And it makes the objective very difficult because on top of the main objective, which is to maximize productivity, we have to add penalties for 35 soft constraints. Now let's have a look at the problem size. As expected, also this problem is very big. The size depends on the business unit of the particular company, but we have problems up to over 4,000 employees, 10,000 jobs, and we're solving typically for the whole calendar year. In contrast to the delivery product, we have more time to solve this problem, about 24 hours. So what are the benefits of using Satalia Workforce? Before using our system, one of our main clients have invested particular employees to solve this problem manually. And because of that, the solution for this often had a lot of hard constraint violations, which was quite problematic. But with Satalia Workforce, the client is now able to have a solution in much shorter time and also a much high quality solution with zero hard constraint violations and much better features such as work capacity or travel time. We also don't know exactly the monetary benefit that our clients have made, but also in this case, we estimate that it's in the double-digit million pounds per year. So this concludes the 2 industrial projects that I wanted to share with you. Now let's move on to the unexpected challenges. Gaining the client's trust. Why is gaining the client's trust such a big challenge? First of all, we have to be mindful that investing into optimization requires a lot of trust from the client side, much more than in other industries or other disciplines. Why is that? The first reason is that clients often do not know what optimization is. Let me give you an example for this. One of our ongoing clients who's already been using our delivery product approached us because they wanted to improve their supply chain. And we had several discussions with them, and after a while we realized that what they would want is to have a visualization tool that would visualize the flow in and out of their warehouse to optimize. Obviously, this is not an optimization problem, and after an initial slight disappointment from the client side and also a bit of distrust because they felt they had a problem but we couldn't solve it for them, with some more discussions, we identified several actual optimization problems in their supply chain. For instance, one of the problems they faced was to find shift patterns for their drivers that would bring products into the warehouse, and we were able to solve that for them. So what this example shows is that clients have problems, but they cannot identify which one of them are optimization problems. They might even have a wrong idea of what optimization actually offers. So we're in a difficult situation. We're trying to sell a product that our customers don't know and don't understand, and they don't even know if they need it. So what can we do about this issue? First of all, we can educate the clients or the general public about optimization. What I mean with educating is to explain to them what optimization problems are, how to identify them, and maybe to understand why they're very hard to solve. I also think we should do that in a responsible way. What I mean with this is that we focus on the whole spectrum of what we can achieve with optimization. I think sometimes the conversation around optimization is more focused on the monetary benefits, such as maximizing profits or minimizing costs. But there are many more features we can improve with optimization. We can maximize staff happiness. We can minimize our environmental impact. And from my experience, a big proportion of clients are interested in these additional features. They care about their staff. They care about the environment. So I think if we talk about optimization, it's good if we talk about all the things we can achieve with optimization and not just the monetary parts. Another important feature to do is to share our success stories, share what we're good at, and not just in the academic realm, but more widely to the public. At Satalia, most of our clients that we win through word of mouth recommendation, because clients share their success stories to other of their partners. Another challenge regarding trust is that it is very difficult to estimate the benefits of optimization. This means at the beginning of a project or when we start a conversation with a client, we cannot estimate exactly how much they will benefit. This means the client will have to take a risk, and they also have to invest before they can actually reap the benefits. This requires more trust. So what can we do about that? Again, it's very helpful to share success stories of similar clients. If a client hears that a competitor or someone in a similar business has made substantial improvements by using optimization, they're going to be more willing to trust and to invest into a similar system. Furthermore, we can also offer specific business models that would reduce the risk on the client side. A good example is a gain share for reduced fees. The idea behind this is that the optimization company reduces the fees for the client, but in turn, the optimization company receives a percentage of the savings or the gain that the client will make by using the optimization solution. This means that the risk is distributed between the client and the optimization company and can further promote some trust between the client and the optimization company. Another important aspect is that the client has many different faces, and we need to have all stakeholders on board to be truly successful. So what are the typical faces you might see at the client? You'll have the end user who is actually using the tool. You have domain experts who are the ones who are currently solving this problem. You have decision makers that decide if a project might move forward or not. You have the technical staff, and you have project management that makes sure that the communication within the client and also with the optimization company is running smoothly. And I could probably elaborate a lot on the different priorities of all these different groups. It's important to consider all of them to be really successful. And for now, for reasons of time, I want to focus on the most important ones, which I think are the end users, the domain experts, and the decision makers. The end users are the people who use the optimization tool in their everyday life. And it's important that they're willing to use the tool, otherwise it's not going to be successful. So let's have a look at the priorities, the typical priorities of end users. First of all, the solution should make sense to them. Now, making sense is a very subjective term. We all know from optimization that the optimal solutions might not intuitively make sense. For instance, in vehicle routing problems, if we look at the routes, at the tours, they might look very choppy and not very aesthetically pleasing. And the end user who sees tours like this might think that they're actually not optimal, and they might not trust the system. They might think that the system is giving them bogus answers. Another priority of end users is that they still want to have the feeling of being in charge, being the main decision maker, and not being told what to do by the system. And another very simple priority is that the tool should be useful. It should not make the life of the end user more difficult. So how can we address these priorities and gain the trust of the end user? First of all, it's important to involve the end user in the design process to make sure we know about their preferences and what they want to actually use the tool. Second, we can cater for the preferences that they have. As an example, in vehicle routing problems, it's not unusual to create more aesthetically pleasing tours in return for investing some extra mileage. Furthermore, what is becoming increasingly interesting, popular for clients, is to provide reasoning tools for solutions. And with reasoning tools, I mean a tool with which the end user can ask questions about the solution to have more trust into the solution. A classical question would be, why is employee A assigned to this job but not employee B? I thought that employee B would be much better for this job. If the end users can pose questions like this about the solution with an interactive reasoning tool, this can dramatically increase the trust into the system, and it will also help them to learn and understand about optimization systems. Last but not least, to give the end users the feeling that they're still in charge and the main decision makers, it can be very beneficial to leave some decisions to the end user. As an example, instead of providing one good solution, we can provide 3 solutions and the end user can choose one of them. Another thing that we are doing with Satali delivery, for instance, is that the routes that are calculated between each order in the tour of the vehicles is only provided as a suggestion to the drivers. The drivers can still decide how they get from A to B. They have a decision support system, but not a system that tells them what to do. And this is very important for the end users. Finally, we can also provide an interactive tool where the end user can actually edit the solutions and make changes. This can be very problematic though, because the end users might introduce infeasibilities that then the system has to repair. Now let's move on to the domain experts. The domain experts are the people who are currently solving the optimization problem at the client. And the type of people who are domain experts varies quite significantly between clients. In particular, the role that they have at the client. Some domain experts might have a completely different role than being domain expert, and they just solve the optimization problem as a small side project out of necessity. At other clients, the domain experts' only job and only role is to solve this optimization problem. Also, the technical background varies quite a bit. But still, all of these domain experts have two things in common. First of all, they know everything about the underlying problem that we want to solve. They know every corner case. Second, their cooperation is absolutely crucial to the success of the project. Unfortunately, the domain experts are also the most vulnerable group at the client, because the optimization tool that we're going to build is going to replace part of their job, part of their role. And depending on how much of the current role of the domain expert, the vulnerability is going to increase. So what are the priorities of this group? From my experience, the main priorities is that the domain expert wants to keep their credibility, and they also want to have job security. How can we approach the domain experts to gain their trust and their cooperation? First of all, I think it's important to approach the domain experts as equals, because they are solving MP hard problems just like we do. Furthermore, we can assert their expertise by acknowledging it, and this way we can assert their credibility as well. Last but not least, I think it's important to be mindful of the company culture. Some companies care a lot about their staff, and they're going to make sure that the domain experts are going to keep their jobs no matter what the optimization tool is going to take away from them regarding their role. Other clients may not. And depending on the vulnerability and the company culture, the domain experts might be viewing the optimization tool that we're trying to build as positive or as a threat. And it's good to be mindful of that. Now let's move on to the decision makers. The decision makers are the people who are going to decide if an optimization project is going to move forward or if not. Typically, decision makers do not have a technical background, and they often do not have much time. The priorities are to see the benefits that the optimization tool would bring and to have very clear deliverables. So how can we gain their trust? From my experience, what helps is to help them to lay out the benefits in a very clear and brief fashion. This means providing them with very tangible figures and numbers, removing and avoiding all kind of technical details. And furthermore, it can help to showcase the actual deliverables. For example, by creating a little mock-up that shows the graphical user interface and shows what the tool is going to be. This is going to be much more tangible than a lot of text. Furthermore, we have to be mindful that the decision makers we're going to talk to are rather going to be at the mid-range of the company. And after we have convinced them to move forward with our product or with our project, they will have to convince their superior as well. And ideally, we make their job very easy by providing them with very concise and clear information. Now, finally, after considering all the different phases of the client, I think it's important to also be aware that gaining the trust is not just something we have to do once, but that we have to do over and over to create a sustainable and permanent relationship with the client. So gaining trust happens over a long period of time and not just at the very beginning of the project. The next unexpected challenge is problem scoping. Problem scoping is typically one of the first tasks in any industrial application project. It means we sit together with the client and we try to gather the requirements for the problem that they want to solve. This is quite a challenging task, and the reason for this is that we have to get the problem right. We need to really understand the problem we want to solve, because otherwise we're going to design a solving algorithm for the wrong problem. It also involves a lot of human communication, which can make it a bit tricky, especially because typically you have domain experts talking with mathematicians. So I want to share with you some tips on how to be more successful with problem scoping. Let's start with tip number 1. As we know from sports, it's important to involve the right people in your team. We need different skills, different expertise. And when we sit together, it's important that all the expertise that we need on both sides are present. I've seen projects where not all of the required expertise was present, and this can cause projects to fail. So from my experience on the optimization side, it's good to have some optimization expertise as well as software expertise present. And on the client side, we want some domain experts, end users, and some decision makers. Tip number 2 is about priorities. As we've already heard before, on the client side, we have a lot of different groups with different priorities. And it's important that we hear all their preferences because all of their preferences matter. In particular, once we have all the priorities, we probably have to prioritize the priorities. Furthermore, we have to identify if there are any conflicts in the priorities. For example, it might be possible that the end users would like to have several solutions to choose from, while management would prefer to have only one solution. And if there are conflicting priorities, they have to be discussed. Because if we only go down one road, another party might be unsatisfied with the end product, and we don't want to be in that position. Tip number 3 is about terminology. So often the clients will have their own domain language about their domain and their problem that they're dealing with. To fully understand the problem that they want us to solve, we have to understand the language of the client. And we don't only have to understand it, we also have to be able to use it. So this is why Zatalia often creates a glossary of the different terms that clients might use. It's also good to be aware that sometimes it can be a little bit tricky. In particular, if some of the terms that the clients use coincide with other terms, for instance, that we use in the mathematical language. A very simple example would be the term constraint. If I use the term constraint, I might think that it automatically implies that it's a hard constraint. But for the client, it might mean that it's a soft constraint. And if we don't clarify these misconceptions about terms, then this can lead to quite some problems and misunderstandings. Scoping tip number 4 concerns acknowledging the limitations that we have when we model a problem. All models are wrong, but some are useful is a quote that definitely applies to problem scoping. We have to be mindful that whatever model we create, it's only going to be a limited view of reality. Also, sometimes we won't be able to add constraints or objectives to the problem. A good example of that is if, for instance, we have the constraint that 2 employees should not be scheduled in the same shift for personal reasons because they do not get along. These are constraints that we might know about, but we cannot really add them to the model for the simple reason that we cannot add database entries where we state which employees get along and which don't. Tip number 5 is about legacy features. A legacy feature is a feature that no longer is necessary, but the client believes that it's a necessary feature. Let me give you an example. We had a client that was using our delivery solution, and they told us that one of their hard constraints is that the vehicles, the delivery vans, have to leave the depot at the same time. And after some further discussion and some questioning, we realized that this is actually not a hard constraint. That they believed it was a hard constraint, they never questioned it. It's just something that they've always done that way. And it can be very powerful for us to debunk these legacy constraints because we can dramatically improve the solutions by removing these constraints. So what can you do to debunk these type of legacy constraints or to spot them? in my experience, it's good to always question any kind of constraint that the client might share with you and understand the reasoning behind it. I'd also like to quote Grace Hopper, which is also known as the mother of compilers, when she said that the most dangerous phrase in language is, "But we've always done it that way." Tip number 6 is more on the serious side and concerns sabotage. So as we've already heard before, and when we talked about client trust, there are certain employees on the client side that might feel threatened by the optimization tool that we're building, often also for good reasons. And it can happen that these employees will try to sabotage the project. Acts of sabotage can vary. What can happen is that they might provide inaccurate information, such as inaccurate constraints or objectives, or inaccurate deadlines. What has also happened once with us is that we experienced a time when the employees would actually sabotage a comparison. So we built an optimization tool for one of our clients, and we wanted to compare the tool to the existing tool that the client has been using at that time. And there have been some employees on the client side that have felt threatened by our optimization tool. And when we compared the two systems, they manipulated the comparison so that their system came out as the more efficient one, even though our system was more efficient. Acts of sabotage are quite rare. Typically, the company culture is a good indicator. The company culture of the client is a good indicator of if it's going to happen or not. Tip number 7 is about communication practices. We all want to have good communication practices, and sometimes it takes a bit of extra effort to make them really apply. What I think helps a lot is to actively listen and make sure that everyone in the room, everyone in the meeting is heard and has a voice to speak. What can help a lot is to create a safe environment that is also relaxed. What can further promote an environment like that is also including some social events, for instance, having dinner with the client and thereby relaxing the atmosphere. Taking notes is also a very helpful communication practice that can be easily forgotten. Tip number 8 is about rushing into it. Be prepared that you will have to take several laps. Even if you try your best in the first round, it's very unlikely that you're going to get it right. So be prepared and don't be frustrated if you have to meet several times. Finally, tip number 9. As constraint programming professionals, we know that if we're going to be bound to fail, we want to fail as soon as possible. And this is the same in problem scoping. What I mean with that is, if you have some initial solutions, share them immediately with the client. The reason is that when a client will look at solutions, it's going to be much easier for them and much more tangible to them than a problem model or a problem description. They're going to immediately see the consequences of their requirements as they have stated them. For instance, they might see that, oh, this hard constraint is actually can be violated in certain situations. So it's not really a hard constraint, it's a soft constraint. So if you're able to share your solutions as early as possible, it's going to help the client better understand if we're at the right point and if we have the right problem formulation. So this concludes my 9 tips, and I'm gonna end them with another statement, which is, even if you've perfectly scoped your problem, be prepared that it will change. So let's talk about the reasons for why the problem will still change even though you've perfectly captured it. The first reason is that the client is still learning about optimization. And while the client is learning about it, they will get a better understanding what it has to offer. This means, especially in the first phases of the project, it's not unlikely that they are going to add decisions that they might want to make, or new constraints or new features, just because they start to understand all the things we can do with optimization. Another reason for change that, in my experience, always happens is that the client will adjust their priorities. This can come from very simple reasons such as new management, but it can also come simply from the client seeing final results or seeing some solutions, and they're going to realize that the priorities they first had are actually not accurate and they want to adapt them. Also with time, clients and companies naturally evolve and change their point of views, and it's important that the optimization tools can also evolve and change with them. So we have to be prepared to change. For instance, our biggest client for our workforce solution has been using our system for several years, and every year we're making new adaptations. We remove some constraints, we add some constraints. And this is perfectly normal and important. So a changing problem description, unfortunately, is a constant in industrial problems. So how do we deal with this constant change? The biggest issue, or one of the biggest issues, is that we have to build an algorithm for a problem that is changing all the time. It's not changing substantially, but constraints are added and removed, and this can be quite challenging. So how do we tackle this issue at Satalia? First of all, we try to use general purpose solvers like CP solvers. The big benefit of these general purpose solvers is that it's easy to add and to remove constraints or objectives, and it won't break the solving approach. This can be an issue when building purely meta-heuristic approaches where adding certain constraints can completely break the solution approach. We had a team that had to learn this the hard way. They built an optimization solution for a client. After a very long scoping period, we thought that the problem is fairly well laid out, but still, as the project started, the client added more and more features, and our team started developing a meta-heuristic approach. And they really struggled to keep up with all the changes and adapting the meta-heuristic approach to all these changes. Eventually, they had to abandon the meta-heuristic approach and resorted to using a general purpose solver instead, which was a very frustrating experience for our team. A second thing to help building algorithms for these kind of changing problems is to anticipate the changes. Often you have an intuition of which kind of constraints might be changed and which might not be changed, or which constraint might be added. And sometimes you can factor that in appropriately when you design your algorithm. Another thing that can help to mitigate the issues is to just keep an open mind. If you have an open mind, it's much easier to be flexible, and it's much less frustrating when new requirements come in. The second issue when dealing with constant change is that we need to build and maintain a software that is changing all the time. This is very closely coupled also to the whole algorithm design, because in the end we're implementing our algorithms in software. Still, I think it's before we start a discussion on how to build ever-changing software, let's have a closer look at what we actually mean with industrial software. So the size of industrial software will depend a lot on what kind of tool, what kind of project we're actually working on. Typically, we will start with a proof of concept project where we're simply designing an optimization algorithm that will be evaluated on some historical data. This is a very simple piece of software where we only take some data files as input. However, a fully rolled out product will be much more complex. We will have a graphical user interface that the user is going to use. They're going to send a request to the decision support system that sits somewhere in the cloud. This decision support system will obtain input data from various databases, and the number of databases can be massive. Some of our clients have up to 20 databases. And then we retrieve the input data. We might have to tidy it up or anonymize data, and then we will forward it to the optimization algorithm. The algorithm again might need some more data from external systems. It might need a travel matrix, for instance, from a routing system. Then it will compute a solution that is going to be sent back to the graphical user interface. So to build a whole product, you need a lot of different expertise, not just optimization expertise. You will need some front-end developers, back-end developers, software architects, etc. Furthermore, I think it's important to look at the different objectives we might have when looking at optimization software. In academia, for instance, we implement optimization software purely for efficiency. The problem we are solving typically don't change, and we have a small number of developers, maybe 1 or 2 people. On the other hand, in industry, the main aim of the software is to be maintainable and extendable. Also, the problem will change, and a much larger number of people is working together on this project. So we have very special requirements when it comes to dealing with ever-changing software. So how do we deal with that at Satalia? First of all, we have very clever software engineers that develop the design and the architecture of our softwares. And we often have discussions about efficiency and maintainability. There's an obvious trade-off. Sometimes we want to go for efficiency, but we cannot to make the product more maintainable. We also apply good coding practices, such as employing high coding standards. We regularly refactor our code. For instance, the code for our workforce solution has been refactored at least 4 times already. Every line of code is code reviewed, and we're very strict with documentation. This concludes tackling constant change. Now I want to talk about monetizing optimization. Monetizing optimization is a challenge that is not project critical. It's more critical to the existence of the optimization company. So what I want to discuss briefly are the 2 different business models that you can use to sell optimization products and what the advantages and disadvantages are of them. The 2 different business models are consulting and selling a product. Now in consulting, you typically build a product from scratch. This means that the consulting fees are fairly high. However, the customization factor is very big. This means we can build something that is exactly tailored to the needs of the customer. Another question is, who has the intellectual property of a consulting project? This depends on the contract. You can either set that the IP belongs to the optimization company or to the client. Now, often for clients, it can be a drawback that the consulting fees are so high. And if you're faced with this problem, one thing you can do is to offer them a gain share. This way they will have reduced fees. So this is something I've already mentioned before. Gain share means that the optimization company will receive a share of the savings that the company has made by using the optimization product. Now, on the other hand, we also have the product side. So when we're selling a product, it means we're selling the license for using an existing product. This means as optimization company, we must have already invested some time and resources into building the product. The big benefit of products are that the license fees are typically much lower than the consulting fees. However, the customization factor is lower and will depend. For clients that have exactly the same needs or very similar needs to what the product offers, a product is extremely beneficial and it will be highly customized to their needs. But on other cases, this might not be the case. The intellectual property also typically lies with the product owner, so with the optimization company. And in case, as an optimization company, you don't have enough funds to invest into building a product, you can also consider co-creating a product together with a client. To give you some context, let me quickly share how Satalia is handling monetizing of optimization. We do both. We do consulting and we also sell products, which is slightly controversial. There are some people who think it's better to either specialize on consulting or specialize on products. For us, it seems to work pretty well to go for both. What typically happens, how our products typically evolved from consulting products. Consulting projects. So what would happen is that a consulting project is very successful, then we would invest into building an actual product of it and selling it. We've also co-created products with clients, and we've also offered gain share for reduced fees. Now this concludes the unexpected challenges that I wanted to share with you. Let me wrap up. I do not want to wrap up by sharing with you the most important points, because I think that lies with you as the listener. But I want to share with you the most important personal lessons that I've learned during industry. First, I've learned that having empathy for the clients and for my colleagues can help me better understand their priorities, where they're coming from, and helps building trust a lot. I've also learned that it's important to question everything I hear, in particular from a client, and to listen actively. I've also learned to expect change, which was not a very easy lesson for me to learn, but it now helps me to be a bit in a more flexible mindset and be less frustrated when change happens. I've also learned a lot when it comes to building clean code and being good with documentation. And as a very passionate software developer, this has been a lot of fun as well. In fact, all of the points I've listed here, this whole journey has been a lot of fun, and I enjoy very much working in industry because I have the feeling I can grow in many different directions: algorithm design, software development, but also my human skills. Finally, I now want to talk about the constrained programming community and the impact that I think it can have on optimization in practice, because I think the CP community has much to offer for industry. First of all, the solving technology of constrained programming is very useful for optimization in practice. There have been very recent advances such as in parallelization, and as I've mentioned before, it's an easy framework to add and to remove constraints and objectives. Another important direction that has emerged recently is reasoning about solutions and enabling trust into them. This is a topic that is already quite hot in artificial intelligence. Topics like explanations, enabling trust, revealing biases, and I think from what I hear from our clients, it's equally important for optimization solutions. And I'm quite excited about the CP2020 AI workshop, Constrained Programming Towards Trustful AI, that I think is its first series this year. At the time of this recording, it hasn't happened yet, so I'm very much looking forward to it. Furthermore, any kind of help we can get to automate or improve problem scoping is extremely valuable for us. This means all the different lines of research that help us to either automate problem scoping or enable the user to do parts of the problem scoping themselves is incredibly precious. For instance, research that has happened in constrained programming concerning inferring models or features from solutions is very, very beneficial, because for clients it's much easier to provide solutions than provide a problem description. Furthermore, the pursuit of the holy grail of computer science, so users simply formulating their problem in natural language, and then the whole process of modeling and solving is done automatically, can also be hugely beneficial for automated scoping. If we can give the user a tool with which they can kind of pre-generate some models, then this will be really helpful. And similarly, automated modeling and model improvement can also play an important role when it comes to automated scoping. So I'm also looking forward to the other workshops that I'm mentioning here on the slide, the workshop for the Holy Grail and the modeling and reformulation workshop. Last but not least, I want to mention modeling tools. Constrained programming is a very expressive language, and it's immensely helpful for rapid prototyping. So I personally use Minisync when I want to create a very quick prototype, or when I want to check if my mathematical model is correct. And I think this is incredibly useful. Finally, I also want to take this chance to say thank you to all the people I've worked together with on applied optimization problems. I've learned something from each one of them, and I'm particularly thankful to my current team at Satalia, who I think are all incredibly clever people and open-minded, and I enjoy working with them a lot. Last but not least, I want to thank you for listening to this presentation, and I'm looking forward to your questions and your comments. Thank you.